So the best way to get good at these kind of problems is just to like do a bazillion of them. So here's 8, which is a good start. So ideally what you should do is you should pause this or whatever, go write these problems down, see if you can figure them out. Some of them are similar to each other, and then come back and see if you got them, or whenever you get stuck, come back and see what you need to do to figure them out. So we'll pretend you did that, and now I'm going to go work all of them out for you. All right, so always remember when you're working these problems that the first thing that you have to do is factor. This one's already factored. Well, there's nothing else to factor on it. This one right here is the difference of squares. So it's going to be x plus 5, x minus 5. Remember, we always say factoring is really, 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 really important, and we mean it. If you can't factor, the rest of all this is just going to be infinitely painful and probably impossible. All right. Then the next thing we want to do is we want to find a common denominator. And we did a whole lecture on this, so this is just practice. So if you missed the whole lecture on this, then this is going to be kind of hard. We found the lowest common denominator, so here we have x plus 5, x minus 5. This is just x plus 5, so a good bet would be that there's a common denominator of x plus 5 times x minus 5. Now over here, this one's already done, so we can just go ahead and pull that in on the top. But over here on the right, all we have is x plus 5. We're still missing an x minus 5. So we have to multiply the top and the bottom by x minus 5. Okay, and to make things a little bit easier, I'm going to go ahead and distribute the 6 across. So I'll have 6x minus 6 times 5 is 30. Now I can combine these, again, all over the same common denominator, x plus 5 times x minus 5. I've got 12x minus, and I need to be very respectful of that minus sign, minus 6x minus 30. And make sure that that stays in parentheses, because what I have to do is I have to distribute that negative sign across, and that's something that we always forget to do, usually. X plus 5, x minus 5. So 12x, minus 6x plus 30. And that's going to give me, again, x plus 5, x minus 5 is on the bottom. 12 minus 6 is 6. 6x plus 30. And that's what you're looking for there. Good? Okay. Let's see if we can simplify that. Actually, we're not done. I almost broke my own rule. We always want to factor these out, because I didn't, for some reason, looking at it, I didn't see that I could pull a 6 out, but I can. If I pull a 6 out here, I've got an x plus 5 on the top. Ooh, and I have one on the bottom. Wow, that was close. Okay. Now that I have an x plus 5 on the top and an x plus 5 on the bottom, and they're all multiplied by each other, it means that I can cross them out, and I'm left with a 6 on the top and an x minus 5 on the bottom. Now I'm done. Ooh, never celebrate too early, right? Okay. So let's try something kind of similar. Here. Oh wait, this isn't similar at all. Let's just try another problem. So again, the first thing I want to do is establish a common denominator. And the LCD on this, let's see, I've got, this has nothing in common with that. So that means the common denominator just basically has to be both of them. Okay? So I've got a little bit of work to do. I've got a 3t here and a 3t here. A t plus 1 here, but I'm missing it here, so I need it here and here. And I'm going to just go ahead and write it out because I think it's going to be too complicated to try to stick it all in that one little spot. Okay. Then over here on the right, I've got a 3t. Let's switch colors at least. A 3t, but there's no 3t here, so I have to add one to the top and the bottom. But I do have a t plus 1 on both sides, so that's good. So 5 times 3t, like that. So now each one has a 3t times t plus 1 on the bottom. if I distribute the 2, I'll get 2t plus 2, and then over here, I'll get 15t. Since I'm just adding, that means I don't have to worry about doing anything special insofar as distributing negatives. Still on the bottom, I have 3t times t plus 1. 2t and 15t is 17t plus 2. And this definitely doesn't factor, so I'm good to go there. Got it? So see, this could be worse. Considerably worse. Keep telling yourself that. Alright. Now in this problem you should see that these actually look very, very similar. One's x minus 3, one's 3 minus x. There's a couple of ways to go about this. One way to do this is to say, okay, I want them both to be x minus 3. So to make this one an x minus 3, I need to factor out a negative 1. And we've done this before on other problems. You might think about it like this: if I factor out a negative 3, or I factor out a negative 1, that would actually get negative 1 times negative 3 plus x, and since it's addition, I can reorder it. And then I can rewrite the plus and negative as a minus 3. And again, if you don't believe me, you can always work it out. And then that's the same thing with this. So I could factor out a negative 1. And that's completely acceptable. So that would be one way to do it. The other way to do it would be to simply recognize that things are off by a negative 1. But ultimately, what you're going to do is you're going to multiply the top and the bottom of this guy by a negative 1. I'm going to write it over here. You're going to multiply the top and the bottom of this guy here by negative 1. So if I multiply the bottom by negative 1, I'll get x minus 3. And if I multiply the top by negative 1, I'll get a negative 9. Another way to do it is just to flat out look at it and say I have 3 minus x. If I want to make it x minus 3, I just have to make the top a negative. You know, to switch the signs on the bottom, I got to switch the signs on the top. So that's kind of a faster way to do it without thinking about it. And it's probably not an advisable way to teach, but anyway. X minus 3 on the bottom, 7 plus a negative 9 on the top. 7 minus 9 is negative 2, and we're already done with that problem. Alright. This guy's kind of fun, I guess. What's important to recognize here is that 3 is actually 3 over 1. So if you want to go ahead and write that as a fraction, just so that you can see it, it's not a bad idea. The lowest common denominator here, between 1 and x plus 3, is actually just going to be x plus 3. This guy here is already taken care of. Now we've got the 1 is fine, but we're missing an x plus 3. So we're going to multiply the top and the bottom here by x plus 3. Distribute the 3 across and get 3x plus 9. 3x plus x is 4x plus 9, and then x plus 3 on the bottom. Nothing factors, and we're all done there. Again, on this problem, the first step that we're going to want to do is to actually go through and factor everything. Out of here, let's see, I can pull out an x, basically. And that leaves me a 2x plus 3. Out of here, I can pull out a 2, I think, yeah. And that leaves me with 2x plus 3. And then I'm just going to leave the guys on the top the way they are for the moment. The next step, finding the LCD, can take a little bit more work. We just got to see what we have in common. Let's see, we need an x for sure, because they both need an x. I have an x there, so that means I have to have an x here in the LCD. There's a 2x plus 3. He's got one already. And now the only one I haven't used is a 2. So I'm going to go ahead and include a 2 as well in my bottom. And that should cover up all the factors I need on the bottom to fill everything out. Okay, now it's a matter of translating it over. So here I've got an x, here I've got an x. I've got a 2x plus 3, and I've got a 2x plus 3. All I'm missing is the 2. So I need to multiply the top and the bottom of this by 2. Same thing over here. Let's see, both sides have a 2 already. Both sides have a 2x plus 3. I'm missing an x, so I need to multiply the top and the bottom by an x to make it match. So 6 times 2 is 12. 2x times x, 2x squared. Like that. I'm going to go ahead and simplify the bottom a little bit just to write it as 2x times 2x plus 3. Up here on the top I've got 12 minus 2x squared. This I can actually factor. I can see that pretty quickly that I can pull out a 2. If I do, that gives me a 6 minus x squared and 2 over 2x plus 3. Since I'm multiplying both the top and the bottom by a 2, I can cancel that out. And now I wound up with x, or 6 minus x squared over x times 2x plus 3. I can't factor this anymore. This isn't a difference of perfect squares, so that's about as pretty as it gets. For this problem again, I'm going to go in, I'm going to recognize that the best step is to go ahead and factor everything. On the left, if I'm sufficiently clever, I'm going to write this. Now you can write it like this, but I don't think that's as helpful for whenever you're going to be doing some work on this in a minute. So I'm going to go ahead and write it out because I need to list it twice anyway. Over here on the right, it's going to be x plus 1 times x minus 1 because it's a difference of squares. The next step is to identify the LCD. It's actually going to be pretty big because I've got 2 x plus 1. So I have an x plus 1, but over here I actually have another one, so I have to include it again. And then I have an x minus 1, so I have to include that as well. And now I've included all the terms in my LCD. Okay. So I have x plus 1 times x plus 1 times x minus 1. Okay? So I've got an x plus 1 and an x plus 1. Got an x plus 1 and an x plus 1. I have an x minus 1 and I'm missing an x minus 1. So that's what I need to multiply the top and the bottom by to make it match. Okay. So I've got 2x times x minus 1. Now over here on the right, I've got an x plus 1 and an x plus 1. I've got an x minus 1 and an x minus 1, but what I'm missing is an x plus 1, so I'm going to have to multiply the top and the bottom over here by an x plus 1. Like that. All kinds of excitement. Okay, so now I'm going to go ahead and multiply everything out. It's a plus sign, so I don't have too much to worry about here. Distribute the 2x, and I'll get 2x squared minus 2x plus x squared plus x all over x plus 1, x plus 1, x minus 1. Combining like terms, I get 3x squared minus x, and I'm going to go ahead and write it like that now if I can get away with it. Can't do much here. If I pull out an x, I get 3x squared minus 1, which isn't anything that's going to factor out with anything on the bottom. So I'm done with that problem. This is similar to a problem we had earlier. We need to recognize that 5 is 5 over 1. Like that. And then to say, okay, so my common denominator is going to need to be that x plus 2. So he stays the same. I have an x plus 2 here, so I have to multiply the top and the bottom of this guy by x plus 2. So 5 times x plus 2. If I distribute the 5, I get 5x plus 10 plus x. So 5x plus 10 plus x would be 6x plus 10 divided by x plus 2. I don't think that there's much I can do here. If I factor out a 2, I get 3x plus 5. And if I'm going fast, it's because I'm assuming you've already worked through these problems. This is more for a reminder, oh, I got stuck on that. So as you're going through these, if you're like, oh, I forgot that step, go ahead and pause it. See if you can continue to work it out on your own, okay? That's what this is all about. We've got one more to do, and this is similar to one that we had before, if not exactly the same as the one we had before. So if you didn't get it before, pause this and see if you can work this problem out, because there was a certain trick to it. And the trick was that if the factors are the same on the bottom, to make them both x minus 3, if I have 3 minus x, I can just change the sign on the top. X minus 3 goes to, or 3 minus x can go to x minus 3 if I change that to a negative 7. And about the only difference here is I have 5 minus a negative 7 over x plus 3, so 5 plus 7, so 12. And we're good to go there.